Let's play some number games in this video. Think of any two-digit number. Now, reverse the digits of this number, add the new number to the first number, divide the number so obtained by 11. Now, have you got a remainder as 0? Let's find out how this game works. Suppose we chose a two-digit number 63. Now, by reversing the digits of this number, we get the number 36. Now, add the new number to the initial number, we get 63 plus 36, which is equal to 99. Now, dividing the number 99 by 11, we get the quotient 9 and remainder 0. Similarly, this game will be valid for all two-digit numbers. Let us now understand why this happened. Suppose AB is a number in which A is the digit in the tens place and B is the digit in the units place. In the first video, we learned that we can write AB in the general form 10A plus B. When we reverse the digits, we get the number BA, in which B is the digit in the tens place and A is in the units place. We can write BA in general form as 10B plus A. Let's add AB and BA. By adding, we get BA plus AB is equal to 11, B plus A in brackets. By looking at this statement, you will realize that the sum of BA and AB is always a multiple of 11. So whenever this sum is divided by 11, the remainder will be 0. Now you must have understood how this game works. Let's play another game. Think of any two-digit number. Now reverse the digits of this number. Subtract the smaller number from the larger number and divide the number which is obtained by 9. You must have got the remainder 0, haven't you? Now let's find out how this game works. Suppose we chose a number of two digits 28. Now by reversing the digits of this number, we will get the number 82. Now by subtracting 28 out of 82, we get 54. And dividing the number 54 by 9, we get a quotient 6 and a remainder 0. Similarly, this game will be valid for all two-digit numbers. Would you like to know why this happens? Let's find out. Suppose we take a number AB in which B is greater than A. We can write this number as 10A plus B in general form. The digits will be reversed to get the number BA, which can be written as 10B plus A in general form. Since B is greater than A, we can say that BA is greater than AB. So let's subtract the smaller number AB from the larger number BA. We get 9B minus A in brackets. By looking at this statement, you will know that the result of BA minus AB will always be a multiple of 9. So whenever BA minus AB is divided by 9, we get a remainder 0. Now you must have understood how this game works. You must have seen the following types of puzzles in newspapers or magazines. Let's learn how to solve them. To solve these, we have to follow two rules. First, each letter represents only one digit, and one digit represents only one letter. Second, the first digit of the number cannot be 0. Let us solve the given puzzle with the help of these rules. We see that the sum of 4 and B is a number that has 3 in its units place. So can you guess what will be the value of B? Think for a while. Let me tell you. If we take the value of B as 9, then 4 plus 9 is equal to 13. This is the desired number with 3 in its units place. If any other digit is taken in the place of b, then we do not get the result as a number with 3 in its units place. In this way, we have found that the value of b is 9. Keep in mind that we cannot take the value of b as 19 because according to the rule, one letter represents only one digit and one digit represents only one letter. 19 is made up of two digits, so we cannot take the value of b as 19. Let us substitute the value of b as 9. Therefore, 4 plus 9 is equal to 13. So 3 is in the units place and 1 is in the tens place. Now in the tens place, we see that a plus 3 plus 1 is equal to 9. That is, if a plus 4 is equal to 9, then what will a be? Think for a while. Exactly. A would be equal to 5. In this way, we have found that a is equal to 5 and b is equal to 9. Let's check that the value obtained is correct or not. Here, if we keep the values of a and b, we get 54 plus 39, which is equal to 93, which is equal to the given result. So, we can say that we have obtained the correct measurements of a and b. Today, we learned some number games. In the next video, we will see some interesting examples related to them. Today, we will see some interesting examples related to number games. Varun selected a 3-digit number, 478. Then he reversed the number, which gave him the number 874. He then subtracted the smaller number from the larger number and obtained the result 874 minus 478, which is equal to 396. He then divided 396 by 99, which gave him a remainder of 0. If Varun had chosen another 3-digit number, would he have got a remainder 0 in that case also? Let us represent a 3-digit number with ABC, in which A is the digit in hundreds place, B in the tens place, and C in the units place. We will assume that A is greater than C. This number can be written as 100A plus 10B plus C. If we reverse the digits, we get the number cbA. In this way, C is now at the hundreds place, B at the tens place, and A in the units place. We can write it as 100C plus 10B plus A. Since A is greater than C, ABC is greater than CBA. So, we will subtract CBA from ABC. ABC minus CBA is equal to 100A plus 10B plus C minus 100C plus 10B plus A, which is equal to 100A minus A plus 10B minus 10B plus C minus 100C, which is equal to 99A minus 99C, which is equal to 99A minus C. What does this tell you? Think for a while. Let me tell you. This means that the result of ABC minus CBA is a multiple of 99. So, if the result of ABC minus CBA is divided by 99, the result will be A minus C and the remainder will be 0. Therefore, we can say that the situation given is true for every 3-digit number. Next example. Find the value of A from the following. Here, we see that if we multiply A with 6, then A will be the number in the units place of the resulting number. Can you guess the value of A? Think for a while. Let me tell you. If we take the value of a as 0, then 0 into 6 is equal to 0. Here, taking the value of a as 0, we get 0 in the units place of the result. So, the value of a can be 0. If we take the value of a as 1, then 1 into 6 is equal to 6. Here, taking the value of a as 1, we do not get 1 in the units place of the result. Instead, we get 6. So here we cannot take the value of a as 1. Similarly, if we substitute the value of a with 2, 3, 4, 5, 6, 7, 8 or 9, then we realize that the value of a can be 0, 2, 4, 6 or 8, but cannot be 3, 5, 7 or 9. The rule tells us that a letter represents only one digit, so the value of a will be one of these digits. So let's find out what the number is. If we assume the value of a as 0, then we get the number as 70 into 6, which is equal to 420, but we will get the result 460 if we substitute the value of a as 0. In both cases, the result is not the same, so the value of a cannot be 0. You can also see that the given result has 6 in the tens place, while the digit in the tens place of the result is obtained as 2. Thus, it is clear that the value of a cannot be 0. If we substitute the value of a as 2, then we get 72 into 6, which is 432. But by placing the value of a in the result, we get the number 462. Here too, we see that both the cases do not have the same result, hence the value of a cannot be 2. Now you stop the video and substitute the value of a as 4, 6 or 8 and find out what the value of a can be. You must have found that after substituting the value of a as 4 or 6, the results obtained in both the cases does not match the given result. But when we substitute the value of a as 8, then 78 into 6 is equal to 468. Similarly, if we substitute 8 in the place of a in the result, then we get 468 again. Here, in both the cases, the result is the same. So we can say that the value of a will be 8. Today, we have seen some interesting examples related to number games. We will see some more examples related to them in the next video. Today, we will see some more examples related to number games. Below is the method of a game. Find out how it works. Select a digit, add it 3 times, multiply the result obtained with 37. Now in all the places in the result, you will have your chosen digit. Let's understand this method first. Suppose we chose the digit 5. By adding it 3 times, that is 5 plus 5 plus 5 is equal to 15. We then multiply 15 and 37 to get 555, in which the chosen digit is 5 in all the places. Now let's understand how this method works. Suppose we chose a number a. To add it 3 times, we will write a plus a plus a, which is equal to 3a. Now we multiply this with 37. 37 into 3a, or we can write 37 into 3 into a. Now we can write it as 37 into 3 into a using the associative property of multiplication. 37 into 3 is equal to 111. In this way, if we multiply a with 111, we get the number which has the same digit in all places. Next example. If P40 plus 3QQ is equal to 8PQ, in which P and Q are digits and no carry-on has been taken in this addition, then find out what will be the value of Q plus P. Here, We have to first find the value of P and Q, for which we are given P40 plus 3QQ is equal to 8PQ. Let's write it in this way. In the units place, we see that 0 plus Q is equal to Q. At this place, we do not know the value of Q. In the next column of tens, we see that 4 plus Q is equal to P. But we neither know the value of P nor Q. So we cannot find the values of P and Q from this equation. Since no carryover is taken in this addition, we can say that P plus 3 is equal to 8 by looking at the column in the hundreds place. From this, we can get the value of P. P is equal to 8 minus 3, which is equal to 5. Now, since we know the value of P, we can find the value of Q using 4 plus Q is equal to P. Putting the value of P in this equation, we get 4 plus Q is equal to 5. That is, Q is equal to 5 minus 4, which is equal to 1. Let P is equal to 5 and Q is equal to 1. See if P40 plus 3QQ is equal to 8PQ. P40 plus 3QQ is equal to 540 plus 311, which is equal to 851. And 8PQ is equal to 851. Both sides are equal, so we can say that we have obtained the correct values of P and Q. Now we will add the value of Q to the value of P. The value of Q is 1 and the value of P is 5. The sum of this gives us 6. That is, Q plus P is equal to 6. So today we saw some interesting examples related to number games.